Okay.
So yeah, so basically, so we have this question. This question is from Kaczor. Right? So this f is an increasing function, and we have this periodicity, and we are given that this limit exists, right? You start
Yeah.
with, so basically, what is this, right? You start with 0, and then you look at like f of 0, then you look at f of 0 by 2, and f of 0 by 3, and so on, and you take the limit. And basically, they're saying that the limit doesn't depend on 0, right? You can start with some other point, you'll end up with the same limit. Okay. Now, this
But
is a
why? I mean, how to understand intuitively that from wherever point I will start, I will reach zero.
okay. So that is what the, so first of all, that is what the question is telling, right?
Okay.
I mean, yeah, but again, intuitively, why do you get? Because so so that because this is a general nature of iterations. Okay, that wherever you start from, okay,
Mm.
you, so it's like, you start from a point and then you apply, but you sort of end up in some special point. Okay, the limit is a special point, and that special point is the same no matter where you start from. So this is the general nature of iterations. I mean, so for example, uh, so one example I gave, that fixed point theorem thing. Okay, but if
Mm.
I want to give another example, then uh, then it could be like this. Okay, that suppose you are given some kind of a recurrence, and this kind of problems are also there in Kaczor earlier, right? You have some kind of a
Mm.
right,
Yeah.
yeah, yeah. You
Yeah.
have some kind of a recurrence. I don't know. I obviously am not writing anything sensible, just writing something. This kind of recurrence. Okay, and let's say that a1. Let's say you start with some x naught. Okay, so this x naught, and then they say, let's say you want to prove that the limit, find the limit. Okay, so
Mm.
uh, so if I have to explain this, yeah, but to explain this, I think maybe I should not go back so many steps. Otherwise, I won't be able to explain this. So I should just do like something like this. So maybe take, let's say, a1 cube plus 1. Let's say like that. So you start with x naught, and an is a recurrence which depends on this, just depends on one previous term. And let's say find the limit is the question. Okay. Now you see, this recurrence we cannot solve. So how do we find the limit? So if,
Okay.
yeah, so if, now you notice what is happening here. If limit, so
Mm.
what am I trying to explain? I'm trying to explain that usually when you are iterating something, then no matter where you
Okay.
start from, the end result would be the same. Okay.
Yeah.
So suppose you started from x naught, and you are taking the limit. You're trying to compute the limit n tends to infinity of a. Okay.
Mm.
Now I want to first say that this limit is sort of like an iteration. How? Well, if you consider the function fx equal to x minus x cube by x cube, x minus x square by x cube plus 1, just the function version of this recurrence in very
Yeah.
loose terms. If you consider this, then you see an is basically f of an minus 1.
Mm.
Right, and so if you iterate this back, you get that it is, right, f of an minus 1 will be f of an minus 2,
Mm.
and then you go back, right? So so an would be f applied n times to x naught. Okay,
Okay.
so you see,
Mm.
all along when you were practicing Kaczor's earlier problems, what you are doing is basically starting from a point and iterating on a function.
Okay.
Okay, but we never realize it because it's the perspective.
Eh,
Okay,
Yeah.
that basically solving this recurrence is like starting from x naught and applying it to a function. Now you know that if the limit is L, you know that if the limit is L, then what does L satisfy? L equal to that, right?
Mm.
So you have practiced this thing, so you would know that this, right? Okay.
Mm.
Now
Yeah.
you see from here, you know that L ke liye there are only few possibilities. At most 4 possibilities. You see the magic. The possibilities and or is 4, maybe only one will be real and sensible. Okay. So you see, there is only one limit that you are getting, no matter which x naught you start from. Right? So you see, so this was in the recurrence language earlier. You started with some x naught, you applied a recurrence, and the limit in the end did not depend on the initial x naught. Now I have translated that problem into this iteration of function problem. Okay, this is the same. Now, obviously, there are some things in that, but this problem is also of a similar nature. Okay. So all these problems are essentially solving for fixed points in some loose way. Because you see, this is also, this limit will be a fixed point of this function. Yeah, so this limit L, right, this will be a fixed point of the function. Why? Because, well, it's easy. So if you take the limit on both the sides, right, then so what is this? This is L, right? So this thing is L. But when you take the limit inside, okay, anyways. So what I'm trying to say is, okay, let me try to say this properly. First of all, frame this properly for myself. The limit is a fixed point is what I'm trying to say. Okay, so I can just explain that from here, right? You're starting with x naught and you're applying this f of x naught and so on, right? I mean, if the limit, if you're taking this limit n tend to infinity, and if this thing is L, again, if f is sensible, then f is, you can apply and you can take the f inside, right?
But it can be only taken when the function, is continuous.
Yes, but I'm saying
or
yes.
It cannot be.
Others it cannot be, right? But I'm just saying that if the function is good, like these functions are good. I mean, x minus x square by x cube plus 1, right? These are all good functions, so you can take it. So I'm saying that then you see this becomes limit of fn plus 1 n tend to infinity. Well, but this is also the limit only, right? This is also L. F of L equal to L. Okay, so yeah. So whenever you start with a point and iterate by a function, okay, you get a limit. If you get a limit, and if f is good, then that limit does not depend on the point you started with. Why? Because it does not. But intuition is that that limit is a very, very special point. It's a fixed point. And usually fixed points are not too many. Again, all this is a usually business. Okay, nothing is always true. Like this pushing the limit inside.
Can you repeat that? Why it is a fixed? Why the fixed point is special? I mean, I didn't get.
Because
how you prove that it's a fixed?
No, it's a fixed point because if L is the limit, then f of L comes out to be L. Right? That is right.
Okay. Yeah.
It's a fixed point, and usually you will not have too many fixed points. At least locally, you will not have those things like. Yeah, I mean, a function will not cut the y-axis infinitely many times usually. It's a good function, right? I mean, just a general common sense kind of thing. It will not always happen. What I'm saying is not always true. None of what I'm saying is always true, but it is true in the good cases to get the intuition. I mean, intuition only is for good cases, right? For bad cases, we need maths. Okay, or whatever. So, so, but this problem is also similar to that, but it is a little different in the sense that you're not just iterating on a function, but you're also dividing by a number. It's a twist in the tail. It's not the same old question. It's more than iteration, right? There is iteration, and then there is a thing in the denominators. But this was just for the intuition. Okay. Yeah. So let me explain this. Try to now do. Okay, so the intuition is clear that this is, I mean, even if like in the question they MCQ and they don't really tell you, they don't tell you that the limit will be same, but by intuition you can tell that the limit will be same.
Okay.
Right. I mean, this kind of, but obviously you have to look at the context. If you go by me and tell is the same and you get wrong, then don't blame me. Okay, it depends on the situation. Okay, now let us come to the business. Okay, so basically it's now it's not a very difficult question. So the point is you have to use the periodicity somehow, right? Periodicity means what? I mean that the function, whatever it is at some point, it kind of repeats, right? So it is usually used to pull the question down to some domain. Okay. So, right. And so what does that mean? Well, it means that as I wrote, I mean, you can prove this by using the periodicity, and I repeat it this way. this, right? So, well, what does it mean? It means that f of x plus n only depends on x. Okay. So, for example, I mean, if you have 10.2, but this will only depend on 0.2. Okay, I mean, so should I say it only depends on 0.2?
I got
Yeah.
it. Yeah, because the 10 will go outside. I mean, the integral portion will go outside.
Yes, exactly. The integral portion will go outside. Okay. So we don't.
Yeah.
So basically, we basically we only focus on the numbers which are between 0 and for the time being and solve the problem.
Yeah.
Okay.
Yeah.
Right. So we
Yeah.
use this and we focus on the numbers between 0 to 1. Now it's not very difficult. So suppose you take some x naught which is between 0 to 1. Now we use the increasingness. The increasingness will tell you that this is less
I
than f.
got it.
Yeah. It is this.
I understand what you said. Yeah.
Right. Okay. So now I'm moving forward and saying that, well, you can do this. Right. Oh, okay. I mean, you cannot do this, but this plus 1. Because I mean, so f of so wait. So how do you get this? No, so I mean, you can certainly say this, right? You can say this, that f of x, because it's an increasing function, so you can say this, right? Now the point is that from here you can use the increasingness again to iterate on this and get that, because you can apply f, right? That's what the increasingness means.
Yeah.
Right? It means you can apply the f. So you get this. Well, now what is there? Now it means that you can divide by n and you will get this. Now you can take the limit. Okay.
Yeah,
But
now I can
the
take.
problem is not yet done, because we want to show that limit of that thing, limit of this thing is also same as limit of f of 0.
Yeah.
Right? I mean, at 0.
And
Other.
yeah, but 1 by n tends to 0, limit n into 1 by n is equal to 0.
But this
And
is not. But this is not
so
1 by n, right? This is f of. This is f
one the same
iterated.
by the same property we can take out like 1 is equal to 1 plus 0. So
Okay, right. Yeah, so this can be done. So, correct. This can be done, and so the meeting will just end. So you just join again. So mostly the problem is done.
okay.
That's the thing.
Yeah,
Okay.
I
So
got it.
just, yeah. So just join again.
Yeah.
Yeah.
Okay.
Okay.